So this one says solve this equation. So this is the 2.7 stuff that we were working with. So this should be the freshest in your mind. I really have x over 1 plus 5 over 1 is equal to 14 over x. Okay. What's my common denominator?
X.
X. What is this one missing?
X.
Oops. This is missing an x. So I'm gonna, if I multiply the bottom, in other words, my lowest common denominator is x. So to make 1 equal x, I multiply the bottom by x, but whatever I do on the bottom, you have to do on the top. I gotta do the same thing here. And then this one already has an x, so I don't need to multiply. So when I'm done, I get x squared plus 5x is equal to 14, all over x squared. But then if I take that equation and multiply it by the common denominator, or no, all over x, and then I multiply it by x, the x's cancel. So at this point, I can solve the equation, or the validity of the equation, just by using the numerators. Once I have it all over a common denominator. And so if I move the 14 over here, I get x squared plus 5x minus 14 equals 0. Now this one's probably a guess and check box method. X squared and then minus 14. So x squared is easy. You can only get that by multiplying by, well, I mean, you could do like 1/2 x times 2x, but usually it's x times x. And then
7, 2. No.
Yeah, it's probably 7 and 2. One of them have to be positive and negative. So 7 here, 2 here.
Negative.
This gives me 2x. This gives me 7x. I want a positive 5, so this has to be negative, right? So I get x minus 2 times x plus 7 equals 0, or x equals 2 and x equals negative 7. Now the only thing I have to do is go back to the original equation and see if I have any restrictions in the domain. Now x cannot equal 0, but my solutions do not equal 0, so both of those are valid. Negative 2 or positive 2 and negative 7. Oops.